Hi, this is Swati Ramya, Assistant Professor, ARDS Department. You are here with me in Operating System and Virtualization lecture series. In the previous class, we were discussing about the process and what is process and the process concepts. We were discussing what is process. Process is nothing but execution of the program. A single program can create a n number of process. Whenever the set of instruction in the program is executed, it will create the process. Suppose the same set of instruction, that is program, is executed 3 times. We have 3 process, and each process have its own memory, and it has own stack. It has separate memory for each process. Virtualization lecture series. In the previous class, we were discussing about the process and what is process and the process concepts. We were discussing what is process. Process is nothing but execution of the program. A single program can create a n number of process. Whenever the set of instruction in the program is executed, it will create the process. Suppose the same set of instruction, that is program, is executed 3 times. We have 3 process, and each process have its own memory, and it has own stack. It has separate memory for each process. Okay, so let's discuss about the components of the process. Okay, a process is more, actually the program is a passive one, process is an active one. Process is more than just a programming code. Okay, so if there is a program in a memory, it's just a set of instruction. It's just like a text in the text file, like that. But process is not like that. It's more than just a program code. Okay, program counter keeps track. We have a list of, let's see the components of the process. For each process we have a set of component. Okay, so let's see this component, starting with the program counter. We have the components like program counter, program code, CPU register, heap, program counter, stack, and data section. Process will have the different states. So let's see what all the states there in a process. It starts from the new, ready, running, waiting, and terminated. So you can understand from the diagram, you could see the diagram, you can understand from that. Okay, when the program is started executed, that is, we loaded the program into the memory, and it is waiting for its execution. So it is new one. Okay, so then the program is executed, it moves from the new to ready state. The program is waiting for the execution, and it is waiting for the CPU time to complete its execution. So it is in the ready state. Once the program got its CPU time, it moves from the ready to running state. Now the process has been running. The process is in the running state, but the process sometimes it needs some memory time or input output hardware time. It needs some kind of resources from the CPU, which is not currently available with the CPU. So while running the process, it needs some resources which is not available currently. This process state will move from the running state to the waiting state. This process will wait until it gets the particular resources which is needed to complete its process. So once it got its input output time, that is, for example, it needs to print something using the printer, or it needs to get some input from the keyboard or from the mouse, but it's waiting for that input output hardware time. Okay, so once it got its input output resources, so again from the waiting state it moved back to the running state, and also it got its resources, external resources, and the CPU is also ready to take this process for the running. Then it moves from the waiting state to the running state. So it starts again running the process. Once the process is done completely, it moves to the terminate state. This is how it works. This is the process, different process states. You have 5 states. It starts from new, when the program is executed and the process is generated, it's a new, and it is ready, and this process is ready for the running state. It is ready for this, it is ready to execution, but the CPU time is not, you are not getting the CPU time, so you will be in the ready state. Once you got your CPU time, it moves to the running state, and the process has been keep on running, and you need some other resources, and you want that some other resources is not available currently, so you will move to the running state, to the waiting state. Again, if you got the particular resources that you were waiting, you take the resources, again the waiting state will be moved to the running state. Once it complete its process to be done, executed till the time it's needed, then it move from the running state to termination state. This is how the process works. Thank you.